All right, moving on to our quadratic functions unit, Unit 8 here. Unit 8 is going to be all about, as I said, quadratic functions, which is going to be a lot of putting together of a bunch of the concepts or ideas that we learned before. Remember back in Unit 3, we talked about a lot of different kinds of functions. One of them that we saw was quadratic functions, and those always graphed something that looked like this. It was that parabola. So it always started at a corner and kind of U-shaped up. That parabola always maps out a quadratic function. So at the beginning of our unit here, let's go over some terminology really quick. A quadratic function is a polynomial with a degree of 2. So you can either write it out with an x term, or should I say an x squared term. So that looks like this one. We have 3x squared plus 2x plus 1. Or you can write it with two factors. So this one has 2 factors, each of them that include an x. Now, in our last unit, we talked about how to factor things. So we should be able to recall that we can take this piece, just this 3x squared plus 2x plus 1, use the AC method and factor them. Factor by grouping, and we should be able to get these two factors, 3x minus 1 and x plus 1. If you multiply these out, or if you FOIL these factors, they will become this piece. So this thing and this thing are actually the exact same equations. Now again, we're writing these equations. We're not using it as like y equals. They have them written as f of x equals. They mean the same thing. Y equals 3x squared plus 2x plus 1 is the same as if we did f of x equals 3x squared plus 2x plus 1. You can do either way. They mean the same thing. The f of x is just called our function notation. So it's letting us know that this will graph a function, not just a relation. So now that we know that we can do a quadratic function that looks like this, kind of as a written out trinomial, or like this, as two factors, and they do mean the same exact thing, let's talk about some of the pieces of them. The x-intercept. Remember, we have two axes, x and y. I'm going to draw my y over here. The x-intercept is the x-coordinate where a graph crosses the horizontal axis. So it's the x value when y equals 0. This is going to happen right here. Here's one of our x-intercepts. It's the x-axis, so it's where it crosses that line. And it happens right here. Those are our two x-intercepts. One way to find that is by setting y equal to 0. So in these cases, if f of x is the same as y and we want y to be 0, we could literally replace 0 right here or right here and solve for those. Let me get rid of those. So that would be one way to find the x-intercepts. Other ways to do it, just by looking at the graph. You can see this is where it crosses those points. We're going to move on then. The y-intercept, I'm going to draw that same little parabola really quick. The y-intercept is pretty similar to the x-intercept, only it's the y-coordinate where a graph crosses the vertical axis. So here we have our y-axis, here we have our x-axis. We need the y value when x equals 0. That's going to happen right here. This would be our y-intercept, not the x-intercept. The x one, there are two, right here and here. The y-intercept, there's just the one. It happens right here. The zero product property. This is going to be very helpful once we have our factors. When the product of factors, so two things multiplied, is 0, then one or more of the factors has to be equal to 0. So what does that mean, or how does that look? If I had two numbers, a and b, and I wanted to do a times b, I'm going to color code mine as I work it out, and I set those equal to 0. So a times b equals 0. Either a has to be 0 or b has to be 0. They can both be 0, that's possible, but let's say a was 3, b would have to be 0. That's the only way you can do 3 times something to get 0. Let's say b was -7, a would have to be 0. It's the only way that they'll multiply up to 0. So once we know one of them, we figure out the other one has to be 0. Now sometimes these numbers, a and b, aren't just whole numbers. They might be factors, art forms of factors, like x plus 3 or x minus 2. So then we'd have to solve for what x would be if that factor is equal to 0. And that'll help us in a couple of our next examples here. So example 1, it'll say factor and solve using that zero product property. So our first step is to take this equation, or this piece of it, this quadratic function, and factor it. So we have x squared plus 2x minus 35 equals 0. Now that equals 0 part isn't very important right now. We can almost just kind of get rid of it. So we're just looking at x squared plus 2x minus 35, and we want to make that factored. Well, remember from last unit, to factor a trinomial like this, we kind of pretend that there is that 1 in front of this piece, and we would do a times c, so 1 times negative 35, and we would get negative 35. Next, we need to find the factors of 35 that would add up to 2. So, if we think of 35 as positive, its factors are 1 and 35, or they are 5 and 7. Those are the only factor pairs that there are. Now, because this is a negative 35, we know that one of these has to be positive and one of them has to be negative. That way they would multiply to negative 35. We also need those two factors to add to positive 2. The only pair that would do that would not be that one. We'd have to use 5 and 7. Now we need to decide which one we want positive, which one we want negative. Well, it would be a negative 5. Negative 5 times positive 7 is negative 35. And negative 5 plus positive 7, when we add them together, that's how we get to positive 2. So those are going to be our two factors. So when we break it apart, so we can factor by grouping, we break it apart as x squared, that stays the same, or 1x squared, minus 5x, we do minus 5 because we had negative 5 here, plus 7x, because this is a positive, and then minus 35. And we still have it being set equal to 0. So here is our expression that we need factored, and we're still setting it equal to 0. Now that we have it split up, we can do factor by grouping, put our pieces together. Out of these two, I'm going to underline the two pieces that we are grouping. Out of these two, we can take x out front, and we're left with x minus 5. Out of these two, we can take 7 out front, or positive 7. That's why it's plus 7. And we'd have x minus 5 here. And again, all of it added up is still set equal to 0. Now that we have our groups, again, remember, x minus 5 and x minus 5, it's happening twice. In one case, it's multiplied by x. In one case, it's multiplied by plus 7. So your two factors that we're going to be using, x minus 5, that was here and here, and x plus 7, x and a positive 7. So these are our two factors that would multiply out to make this trinomial, or this equation. I'm going to get rid of that 1. This piece you see here is exactly the same as this piece. The only difference is this is written out in a trinomial, this is written as a factored form. Now that we know we've got our two factors, x minus 5 and x plus 7, and we have them set equal to 0, well, our zero product property would tell us one of them has to be 0. So what if we wanted this blue one to be 0? What would x have to be so that x minus 5 equals 0? Well, x would have to be 5, because 5 minus 5 is 0. So that one's nice and easy. That's one of our possible solutions here that would make this true. Same thing. Looking at our red factor, x plus 7, if we wanted that to set equal to 0, x would have to be negative 7. So these are our two possible solutions. X can either be 5 or x can be negative 7. That would make this piece true. If x were 5, then 5 minus 5 is 0, and 0 times anything equals this 0. If x were negative 7, we'd plug it in right here. Negative 7 plus 7 is 0, and 0 times anything is 0. So these would be our two solutions. Moving on to another example here. B. Again, we're just factoring and solving using the zero product property. In this case, we don't have a 1 out front, we have a 2. So when we do our AC method, we have to do 2 times 9 to get positive 18. Now, looking at 18, its factor pairs are 1 and 18, 2 and 9, 3 and 6. Now we need the pair that's going to add up to negative 9. Because this number, 18, is positive, and this number is negative, that means either both of these have to be positive, or both of them are negative, because this one is positive. And because this is negative, we know that means we're looking for two negatives. So I'm going to go ahead and just write in, negatives in front of all of these right away. Because negative times a negative makes a positive, negative plus a negative would make another negative. So, which of our two factor pairs would add up to negative 9? Well, these would be negative 19, these would be negative 11, 3 and 6. Negative 3, negative 6, those ones will add up to negative 9. So that's going to be our factor pair. That's how we break it apart. 2x squared stays the same. This piece, I'm going to underline it, the negative 9x, we break it apart into negative 3x and negative 6x. So there it is, minus 3x minus 6x. And we keep that plus 9 right here. Now, again, we can factor by grouping. We've got this group, and we've got this group. As we break it all apart, we can take x out of this piece. X on the outside would leave 2x minus 3 on the inside, which tells us then for sure we want 2x minus 3 here. We would want a 2x minus 3 on this side. How would we get 2x minus 3 from these two pieces? Well, we'd have to take out a negative 3. That's why there's a minus 3 on this side. Negative 3 times 2x is minus 6x. A negative 3 times negative 3 makes positive 9. So that's how we were able to break these ones up. Taking this a step further then, to get it down into just its factors, we have 2x minus 3 in both cases. So that's going to be our first factor. Then we have this extra little piece, this x minus 3 has to be our other factor then. 2x minus 3 and x minus 3. If we were to FOIL these out, this would come back to this equation right here. And we still have it being set equal to 0. So when the question asks up here, factor it, this is our factored form. It also asks us to solve it. So again, we need to look at each piece and say, what do I need to do to get this set equal to 0? What do I need to do to get this set equal to 0? Because if this is 0, 0 times anything is 0. If this one is 0, then 0 times anything is 0. So we need to find our two cases where we can make that true. To save yourself some time on some of these, you can literally just take each of those factors, each piece, and set them equal to 0. 2x minus 3 equals 0. X minus 3 equals 0. And solve from there. So looking at our two pieces, on both cases, I think we can just add 3 to both sides. So we get 2x equals 3. In this case, we can get x equals 3. Here we already have x alone, so that's one of our solutions. X equals 3. That's one of the spots that's going to make it true. This one we're not quite done with. We need to get x all the way alone, so we divide both sides by 2. And in fraction form, we would have x equals 3 halves, or in a decimal form, whichever you prefer, doesn't really matter, we would have x equals 1.5. So you can either say x equals 3 halves or 1.5, and the other one that makes it work is x equals 3. These are the two solutions, or the two values of x that you could plug into this equation and make it true. And if you can plug it into this equation, you can also plug it into this equation, and it'll make it true as well.